Assalamualaikum. Alright, in this video we are going to discuss on the squeezing theorem, where in the previous video we just focused on this squeezing theorem given by limit s approaching 0 of sin x over x which is equal to 1. But the other one is actually quite infamous. So we have that limit s approaching 0 of 1 minus cos x over x. It is actually 0 over 0 case, but it is equal to 0. All right, so you have to memorize these two. So let's just see some examples of using the highlighted limit of squeezing theorem now. All right, so we have this number 1. All right, so if we have this, so we have this 4 here, so we can factorize 4. So we'll have something like limit x approaching 0 of 4 bracket of 1 minus cos x over x. All right, so our aim is to put these together, so we can take these 4 out of the limit because it is the number or a constant. So we'll have kind of 4. All right, so we have limit as x approaching 0 of 1 minus cos x over x. All right, so we know that this part is given by the squeezing theorem where the value is actually 0. So since the value of 0, so 4 multiplied by 0 will get 0 as the final answer. All right, so number 2. All right, so number 2, we have something like this. If we try to substitute the value of x with 0, so cos of square of 0 will be 1. So 1 minus 1 will be 0. And then we have the 2 multiplied by 0 at the denominator will be 0 over 0 case. But we can solve this using the squeezing theorem, where in this case we have to use this one. All right, so to do this we have to factorize the numerator first. So this is actually 1 square. So using the properties of factorization, where if we have a square minus b square, so this can be factorized as a plus b, a minus b. So we can rewrite that 1 square minus cos square of x will be 1 plus cos of x, 1 minus cos of x. All right, we have something like this, the whole thing over 2x. All right, so we try to take these 2 out of this limit, so we'll have something like 1 over 2, not 2. Be careful. So I'll have limit as x approaching 0. All right, so I'm just write the first part first. So of that 1 plus cos of x, I'm going to put it in bracket. All right, so now I'm going to focus on this part where I'm going to put this 1 minus cos x over x. So I'll just write another limit as x approaching 0 because it is a product of 2 limits now, so of 1 minus cos x over x. So this is actually 0 by using the squeezing theorem. So we'll have something like 1 over 2. All right, so that one is, we try to substitute 0 inside this, we'll get 1 plus cos of 0, and that one is given by 0. All right, so right, never mind, we'll just try to substitute the value of cos 0 will be 1 plus 1 multiplied by 0. So this one 2, right, that one 2, 1 over 2 multiplied by 2 multiplied by 0, but finally we'll get 0 because we multiply everything with the 0. Alright, so let's move to this question. So we have this. Alright, so if we try to substitute the value of x with 0, so we'll get 0 over 0 case. So instead of substituting it directly, so we'll have to modify it a little bit, and we'll have to use the what we call squeezing theorem of the second part of this one. Alright, so to do this, so we'll have to recall the, what do we call it as, the identity, the trigonometric identity, where we have, right, so if we have sine square of x plus cos square of x is equal to 1, so if sine square of x is actually equal to 1 minus cos square of x, right, so we're going to substitute this part into the function at this part. Right, so we'll have something like, all right, so firstly we'll have limit as x approaching 0 1 minus cos square of x. So note that this one has already been changed to this. At the denominator we have to factorize x, so we'll have x 1 plus cos of x. All right, So it's almost there. It's almost the same as this part, all right? So we have to factorize the numerator, where 1 is actually 1 square. So we will have what limit as x approaching 0. All right, so that one we have to factorize will become 1 plus cos x, 1 minus cos x. All right, so everything over x, 1 plus cos x. And we can cancel the term which are the same in the numerator, also denominator, which is in this case we have 1 plus cos x with 1 plus cos x. So we are just left with the limit as x approaching 0. So we'll have 1 minus cos of x over x. So this is actually using this squeezing theorem. So limit as x approaching 0 of 1 minus cos x over x. This is actually equal to 0 by squeezing theorem. So we are done with this one. All right. So I've got some a request from one of the followers on YouTube. All right. So it's one of the subscribers from the YouTube. So where he wants me to discuss a little bit on this limit as x approaching 0 of sin x over x involving the cotangent. All right, so let's just see this first example. So we have this. All right, so we know that cotangent is actually, all right, so just recall that cotangent x is actually 1 over tangent of x. All right, so 1 over tangent is actually given by cos of x over sine of x. Okay, so we know that cotangent of x is given by cos of x over sine of x. So we'll have to what we call it as substitute the cotangent of x with cos of x divided by sine of x. So we'll have something like limit as x approaching 0. So we'll have x cos of x divided by sine of x. So this part is actually at the numerator. So we want it in the form of sine x over x. So we should modify this a little bit. So we'll have something like, all right, so I'll just write product of two limits. So x over sine of x multiplied with the limit of as x up to 0 of cos of x. So we'll have something like this. All right. So now this part can be directly substituted with the value of x, which is equal to 0, so it will become 1, because cos of 0 will become 1. But this part, all right, we have to modify a little bit before we could use the what we call a squeezing theorem. So we'll have to modify a little bit. It will become limit of as x approaching 0 of 1 over sine of x over x. All right, only then we can use the squeezing theorem. For this part, all right, we try to substitute the value of x with 0, so it becomes cos of 0. So cos of 0 is actually 1. So we will have it something like, okay, 1 over limit as x approaching 0 of sine of x divided by x. All right, that one multiplied by 1. So we know that this part is actually equal to 1 by squeezing theorem. So we'll have 1 over 1 multiplied by 1. So our final answer will be 1. All right, so let's move to question number 2. We have cotangent of 2x over cotangent of x. Okay, so the first thing that we have to do is to convert the cotangent into this form. So we will have, right, this as, all right, so limit as x approaching 0. All right, so I'm gonna write cotangent as cos. All right, so cos of 2x divided by sine of 2x. That one is cotangent of 2x now divided by cos of x divided by sine of x. So this one is cotangent of x at the denominator. So we have something like this. So we have to modify a little bit. We'll have something like limit as x approaching 0. All right, I'm gonna write it properly. So cos of 2x over sine of 2x. That one is divided by cos of x divided by sine of x. Okay, so I'm gonna convert the division into multiplication. So we'll have something like limit as x approaching 0 of cos of 2x divided by sine of 2x, and that one converted to multiplication. So we'll have sine of x divided by cos of x. All right, so we we have to put the sine of 2x with sine of x together. All right, so if we try to substitute the value of x now, it will become 0 of 0 case. So what we can do is actually we can put that limit as x approaching 0 of sine of x over sine of 2x. Okay, that one we put it together, and for this part, all right, I'm gonna color it. We put cos of 2x over cos of x together, so we'll have something like cos of 2x divided by cos of x. Right, so I'm gonna distribute this limit to this part and also this part, so we will have something like, all right, limit of x approaching 0 of sine of x divided by sine of 2x. All right, that one you have to multiply with limit as x approaching 0 of cos of 2x divided by cos of x. Okay, so now we have to divide each term here at this part with x, so that will have something like, all right, so I'll just write it here, limit as x approaching 0. All right, so I'm gonna write sine of x. All right, so our intention is divide this by x, so we have to divide this by x, so we'll have something like, all right, I'm gonna write it properly, so sine of x divided by x, so we'll have sine of 2x divided by x also. All right, so each denominator and also numerator will be divided by x. All right, so for this part we can substitute the value of x with 0, so we'll have, all right, cos of 0 divided by cos of 0. All right, so we'll get 1 over 1, so it will become 1. All right, so for this part we have to modify these. All right, so that we want this 2x here. All right, so we have to put 2 here, but you can't simply put 2 there, you also have to put 2 at this part. All right, so it will become something like this. All right, so I'm gonna have something like, all right, I'm gonna write limit as x approaching 0 of, all right, so for that part at the numerator you just leave it as sin x over x. At the denominator you can modify. All right, so you put 2 first. All right, so you'll just put 2, and then I'm gonna put that sine of 2x over 2x together, so I'll have sine of 2x over 2x. All right, so that one multiplied by 1. All right, so I'm gonna distribute this limit as x approaching 0 to the numerator and also denominator, so we will have something like limit as x approaching 0 of sine of x over x divided by 2 limit. All right, meaning that we'll take out 2 outside of the limit because it is constant, so 2 limit as x approaching 0 of sine of 2x divided by 2x. All right, so that one multiplied by 1, so we'll have the numerator as 1 over 2 multiplied by 1 multiplied by 1, so this, all right, so this is 1. All right, so we'll have the final answer as 1 over 2.